Hello, everyone, and welcome to Handmade Heroes, show where we code a complete game live on stream. We are gonna do movement modes today a little bit more formally. We sort of have them working already, but it's kind of a little fast and loose, and there's I think enough slop in there that I wouldn't really want to leave it as arbitrary as it is right now because it's pretty close to being something that I think could be relatively reliable and work a little more cleanly. So I think that's what I would like to do. And so that's what we're going to do. Since we now have brains working relatively solidly, and we tested that out, we built like some interesting creatures yesterday. And so I'd like to take a look at that movement mode stuff and kind of clean that up a bit. And I think that would probably get us to the point where I'm relatively comfortable with how we're doing sort of all of the behavioral stuff in the in code, because it seems like we're able to write relatively directly what we want at this point, and I don't have a whole lot of architectural concerns about it. I would like to like I said, address the movement mode stuff, and then we're gonna probably have to take a look at how we're doing world construction, because right now it's a little bit overly verbose, and like how you pass things around and with the world chunks and so on. And we've got the spatial query stuff as well, which we kind of want to handle. So there's a bunch of things like that that we would like to figure out, and that's what we will be dealing with over the next couple days. So let's take a look. Today is day 293. I am going to go ahead and jump right in. So if you want to follow along at home, unzip day 292 source code into a directory, and that is what I'm starting with right now. So you can see kind of where we left off back yesterday. We've got a bunch of things running. We've got this little snake dude here who just kind of snakes around, and we have Monstar who hops around randomly. And we've got a familiar who just kind of randomly pushes towards the player, but we haven't really done anything with that yet either. And one of the things that you'll notice is that although our hopping movement mode, right, the hopping movement mode is the one currently being used by almost all the entities on the screen. The snake uses the hopping movement mode, the Monstar uses the hopping movement mode, the hero uses the hopping movement mode, but actually the familiar who has flown off the screen doesn't use the hopping movement mode, because obviously it's just this kind of floating head. And one thing you'll notice about that, and I could go find that familiar, I suppose. I don't know where he went, probably up here somewhere. Well, there's a different familiar, so that's fine. One thing you'll notice about the familiar is that it does not actually occupy any square other than the one that it started on. Oh, back over here you can see it's still technically occupying this square, right? And that's because it doesn't really have a movement mode of its own. It's just kind of being moved around by the brain arbitrarily. And that's essentially equivalent to what's happening with the head of the hero here, right? This head. And that, we want to probably change a little bit the way the hero's head is moving as well, but we definitely want the familiar to not work that way, because it basically is just totally bogus. What we want to have happen is we want a movement mode for floating, where as you float around, you try to occupy the square that you are going to be most underneath, and if that square is not available, you should be stopped from going there, right? You should not be allowed to actually enter a square that's occupied just because you are floating, right? And right now we wouldn't, we cannot, like anything that's in the hopping movement mode, right, it cannot enter there. See how I'm clearly moving over here, and we don't try to stop the head so I can just keep on going, but the body will never try to do the hop, right? It's like completely stuck there, right? Which is exactly what we want. So yeah. So we need that same logic to happen inside floating entities, because unlike something like a projectile, which perhaps would just be allowed to float around, and when it hits something, it just does damage to that something, or who knows what else we want to have happen. Unlike a projectile, and a floating entity is still going to be considered an entity most of the time. And we can always turn that off if we don't want it, but we certainly want the ability for floating entities to be considered occupiers of squares so that other people can't move in there and so that they cannot move on top of other squares. And so that's what I kind of want to take a look at today as we improve this movement mode code to be a little bit more formal and to have, real alternative movement modes instead of just the one hopping versus planted, which is currently the only thing that's actually in there. So if I take a look at the entity, you can see that the entity has a movement mode enumerator, and that movement mode enumerator only has two things, which is planted and hopping. Most things are in a planted mode by default. Hopping mode is what they engage when they hop from one square to another, which certainly a number of enemies the hero will certainly be using. But we will probably have floating, or just we probably don't have to call it floating. We could call it like sliding, right? Because we don't really care whether the thing is technically floating or technically walking from one square to the other. The point is that it's not a hop. It's a smooth, sort of linear movement from one place to another is really the only part we actually care about. So we could say movement mode sliding, and that would be enough information, I think, for basically most things that we're going to move in that way. And I don't know how many more of these there would be. And I'll be completely honest with you, it's possible that the movement mode stuff really, I don't even know, maybe we only need one movement mode, and that the hopping part is really just sort of dressing, and maybe entity movement mode is more about a look than anything else. I don't know. But for right now, I think we're just going to say, all right, there's a planted, there's a hopping, and there's a sliding. And so when we see sliding, we're going to, sort of move someone from one square to another in a more continuous fashion or something like this. That seems pretty reasonable to me. Yeah, because planted movement mode implies that you are fixed at the location. And that's relatively important, I think, because if you are fixed on your occupying location, that means when it moves, you would move as well. And so I think sliding perhaps also indicates another thing, which is that you're moving of your own volition separate from the motion of the point that you might be standing on, if that makes sense. And now that I think about it, that may be a good reason why we would distinguish floating from other things. I suppose that means we might actually want floating, because when you are floating, you would not, if the points that you're occupying are themselves moving, a floating entity doesn't move with them, right? That seems right to me. Yeah. So anyway, let's take a look at that and see what we want to do here. And there's one possibility. There's another possibility too, which is that it's possible that movement mode floating is actually redundant with movement mode planting, and we'll find that out as we start to clean up the code. And that really, there's just two things. There's, they're both the same because you're always talking about a displacement relative to one of the points, and you can accomplish that by sort of adjusting your displacement relative to your home point or something like this. So I don't know. Yeah, that's basically it. Okay, so let's take a look at that and we'll see where we're at. I'm not 100% certain how this is going to play out, so I just want to kind of play with it for a little bit and see. All right, so here we are in our world mode, which is where the movement stuff takes place. You can kind of see here we've got the code for planted versus hopping, and this is where we're doing sort of that simulated bounce effect that we were using before. And we really don't do any other physics besides whatever that sort of faux hopping is, and then this move entity call, which is really something we're going to replace pretty soon because it's way more complicated than it needs to be for any particular purpose in this game. And we never really wrote it right to begin with. We were just kind of playing around with collision detection, and I was sort of showing some stuff about it when we wrote it, but it's not really appropriate anymore for what we're doing. It's you can't grind up against walls and stuff in this game because you hop specifically from a square to another square and stuff like that. So the kinds of stuff that we were having it handle are not super important to handle anyway for this particular game. So anyway, what we would like to do, I think, is we'd like to say that, when I have something like the familiar, and that's in brain.cpp here. When I have something like the familiar, what I'm doing right now is I'm saying I want him to move in a particular direction, so I'm stuffing his DDP, right, which is his acceleration that he wants to have. I'm stuffing his DDP with the acceleration I would like to give him. And the problem here is that when I stuff that acceleration, it's just going to apply it directly to the object. And again, it doesn't matter, it doesn't think at all about what square I might be on or what square I might be trying to move to or any of those things. And so that's why we never update our occupying, because normally the updating the occupying would be here in the brain code, and now it's not going to be. So again, trying to think through how we want this to be handled, and I don't really know. We've got this sort of concept that we could do it sort of similar to the way the hopping works, which is everything is handled over in the brain, and it thinks about where you're going to be occupying and where you're going to move to and that sort of stuff. The other way is that it's handled more in the entity code as part of the movement modes. And like I said, I'm not really sure which one of those we want to do. Similarly, because I'm sort of saying that the movement mode concept is in question right now, and I'm just sort of trying to think about where we draw the delineation, architecturally speaking, between who does what, you could also imagine that in here, we could say that stuff like where I'm trying to move to is not maybe handled directly in the brain code. Maybe only requests for movement are handled in the brain code. I don't know. But my suspicion, and this is just comes from having built the snake, right? It was very easy to make that snake. I mean, the amount of code we needed to make the snake is like so tiny. And if you think about how complicated a movement that really is, it's kind of awesome that it was this easy to make a snake that works completely perfectly and can never get into any state where it's like occupying its own region or any other those sorts of things. It's completely robust. That was pretty cool. And one of the main reasons we were able to do that code was because the brain issues the transactional occupy instructions right inside itself. And so that's kind of a thing where, it feels like we want these sorts of things to be kept at the brain level. And insofar as there might be ways for resolving them, we would want to at least, if I am going to push it down a level because we want it to be sort of solved simultaneously or other things like this, I think we still want to look to the snake as an example of how easy this was to write, and I think we want to make sure we don't destroy that ability by making it too complicated to be able to write such a simple piece of code to do such a complex motion, right? So so that's the tricky part in my mind. So let me think about this for a second here. And let's just start writing a little bit of code so that I can get my head around exactly how this stuff has to work. So if I take a look at what happens with the familiar, I'm stuffing the DDP here. And what I probably want to know is I want to know if I can keep accelerating in that direction or not, right? I probably want to do a spring back to my home square as well that sort of critically keeps me from getting into the next square if it's not something I can occupy. So I feel like I could implement this particular thing relatively simply by just saying, well, we've got that kind of get closest traversable bit here, right? We've got this notion, where are we here? Here's brain time familiar. I've got this notion that I could say, well, you know what, I should probably also say that this whole thing, since the familiar is just a head, we don't really need to do anything if we don't have a head, so I don't really need to keep checking. So, you know, we've got this head, and we're going to find out what the closest traversable is to it. And we want to know if that closest traversable becomes a traversable other than the one that we are occupying. And if it is a one other than we're occupying, we want to take that new square, right? So we want to say something like, and we'll just do it this way, you know, if I think we have a traversable like check, right? We have the ability to see if they're equal like this. So we can say something like, okay, you know, if these guys are equal, if the closest traversable is the same as the one we're occupying, we don't have to do any work. If it's not, then we're going to want to do that swap, right? So then we want to do a transactional occupy, and again, just bringing up that code here so we can take a look at that. Here's transactional occupy. We're saying that the head has a dest ref, which is our occupying ref, right? That's the place we were, and there's a place we're going to go to, and that's this traversable, right? So if we can transactionally occupy the square, that's good for us. If we can't, we need to know that because we're going to have to not continue to accelerate in that direction, right? But for now, I'm not going to do anything else. I'm just going to verify that that allows the head to float around and occupy whatever the closest square is to it. And you can see that it's happening now, right? So now at least I couldn't move into the same square as this guy, right? And so, you know, I have to hop over whatever his occupying square is. But as you can see, he's still free to float anywhere. So the fact that he is occupying the right square is good, but we want him to have to stop if there was something in his way, right? And so clearly, after we do this transactional occupy, in here, we probably want to do something where we say, if the transactional occupy doesn't succeed, or rather, if we are not hovering generally over our closest traversable, then we have to spring back to that traversable, and that's just a rule or something, right? So, you know, we'll have a thing that's like blocked equals false or something. And what we'll say is when we do get closest traversable, or you know what, let's assume that blocked is true. And then what we'll say is, well, if we get the closest traversable, right, we can say, are they equal? And if they're equal, then we'll say that we're not blocked, because that means we're floating over the place we're supposed to be floating. And if we're able to transactionally occupy the new square, then that would also mean that we aren't blocked, right? But any other case, we are blocked. And so then we can say, well, you know, if we're blocked, we do one thing, right? And if we're not blocked, we do another thing. And really, we don't need to do this checking cure at all. And we're going to get rid of that because I guess that's just true from now on. So we're going to go ahead and grab this guy out here. I'm going to put inside this this loop, I'm going to put this thing because we don't need to search for someone to follow if we're blocked. Because if we're blocked, we have to return to our square first, right? So we don't want to do that at all. So if we're blocked, we want to apply a spring back to the traversable location. And so we'd want to do something like, you know, whatever the traversable position is that we actually are on. So it's head occupying, and I think we want to do a get sim space p of that, I believe. If you remember, we can ask the simulation where a particular traversable is. So sim region get sim space traversable, right? So we can say that this is our target now. And really, I guess now that I think about it, we could apply this logic always, probably, right? We could apply this logic always. And I could just say that if we're not blocked, we look to see if there's a different target. But if we are blocked, then we'll just use this logic here. right? So I'll say the target is the sim space traversable for our occupying point, and we just update that. Target equals closest hero P. In the case where we have a different place we could go, right? Meaning we're not blocked, and we found somebody to follow, right? So yeah, so the problem with that, in some sense, so we're using the closest hero distance squared. So I'm gonna get rid of the fanciness here a little bit, and I'm just gonna say, like, we've got our acceleration times this distance. I'm not gonna probably play with any other aspects of it. I'm just gonna leave that the way that it was. Okay, let's see here. What else we got? All right, so that's a little uncompelling. Target peak is if we're not blocked, and blocked is assumed to be true. If we get the closest traversable and it's equal to what we're on, blocked becomes false. Transactional occupy of the thing, then block would also become false. If we can't get the closest traversable to our P, then we'd be, yeah. So that all seems fine. We'd find the occupying P for the target. That all seems reasonable. Yes? That all seems reasonable. So I want to step in there and see why that's not moving. Why am I not moving? All right. I should probably move those in here as well, since they're not really relevant. That's interesting. So the traversable and the head's occupying location are not the same? That's a little peculiar, wouldn't you say? I wonder why that's true. The traversable at the moment, I would like to see what it is. Head occupying and traversable. So by default, we're on index 0 of this entity here, right? And when we get the closest one, that sure looks the same to me. Entities are the same. The indices are the same. References are equal. This is the I see. So we have a valid entity pointer in both cases, but we don't have a valid entity index in both cases. Meaning, when we initially set it, well, I'll be honest, I'm not sure why that would be the case. I'm not sure about that. So that's saying that the traversable that we retrieved did not have a valid index for some reason. But since it must have had a valid index originally, do we just not set it in there? I'm sort of confused about that. Let me look at that. I think that's a little weird. So where's get closest traversable? Or what get closest traversable? Aha. So we never set this, and I think we should. Because that way, if we're trying to have both of these things work, we can always guarantee that they're set properly. All right. So that was just a bug in get closest traversable. Okay. So now we are at least only accelerating this guy when he believes himself to be able to go into a square, and if he doesn't believe he can go into a square, he'll accelerate back to his current one. Unfortunately, he has enough momentum that it's easy for him to overshoot, right? So this is our spring situation again. You can see his behavior there, like he will eventually come to rest in a correct fashion, but without any damping, he's just going to oscillate forever. So we need to sort of give him something more like the head spring has on the main hero, so that's, you know, so that he has a little more restitution there. And you can kind of see, you know, we use sort of the standard proportional derivative controller style, PDC, or, you know, basically a spring. Proportional derivative controller is, I don't remember if I gave that definition on the stream, but basically, like, yeah, if I flip over to Milton, I can just say that one more time in case I forgot to say it originally here on what, day 293. So there's proportional derivative controller, and this is oftentimes abbreviated PDC. And there's also, similarly, this can actually be an integral as well. So there's proportional derivative controllers, which are PDCs, and proportional integral controllers, or PIC. The formula for a proportional derivative controller we already went over, right? It's that the acceleration of this thing, whatever it is, and it's usually like the acceleration given some particular position, right? I'll actually write it this way. So the acceleration of this thing is going to be equal to something on, you know, it's not a good day for math. Let's do it this way. So the second derivative of my location, my position, is going to be equal to some kind of a constant on, you know, like the 0th order constant or whatever, some tuning value for my spring, the strength of the spring, if you will, times the difference between where I am and where I want to be, right? So it's basically some target value for my position minus the position I'm actually at. That's going to determine how much acceleration I have. And similarly, I'm going to add in a term for the velocity here. So I'm going to add in some other coefficient, and that coefficient is going to make it so that my velocity target minus my current velocity also has a coefficient on it. And so basically what this is it's trying to drive these, assuming that these coefficients are both going to be positive, right? Meaning I'm trying to drive towards these target values. I'm always going to be accelerating in a way that tries to make these things zero, so that tries to bring these things together, right? Because only when I have a 0 here and a 0 here will this actually become 0, right? And so my the reason it's called a proportional derivative controller is because, hey, there's a derivative in it and it's proportional. I don't think there's really much more to it than that. I guess, to be honest, I don't really know where this part comes from. I guess if I had to say the proportional derivative controller part, I'm not sure if it lines up properly with the proportional integral controller, because I'll just think out loud here. this thing I really probably would have called delta. And the reason I would have called it a proportional delta controller is because it's really not about the derivative, it's about the delta between two things, right? And it doesn't really matter what they are, and the fact that I have a zeroth order and a first order is hardly a good reason to call it derivative. And the reason I say that makes more sense is because the other kind, which is a proportional integral controller, what that does is it accumulates this value over time. So basically what happens is every time step I sum up how far I have been off, so that the terms get stronger and stronger the longer I am off, as opposed to only being about the instantaneous difference. And so delta feels a little bit better to me instead of derivative, but I mean, who knows? I'm not a mathematician, so maybe this is fine. Anyway, so that's, again, we went over those in some detail when I first introduced the concept, so I'm not going to belabor the point here. Point being is we need some additional terms in here. We probably need this to be a pretty stiff spring, and we probably need to go ahead and say that we want, I guess I'll just bake the negative in there, because we're basically doing a zero velocity minus my current velocity kind of a thing, right? But so I can just bake the negative in there and not bother with that. So we want some negative coefficient on here. I don't know what it should be. Let's say it's negative 4.0 for now. I don't know, and then we'll tune it, and we'll see what it actually should be. So now we can kind of see that that our little friend here is a little bit. He doesn't move in a very satisfying fashion, right? But he's moving fairly correctly now, right? And one thing I could do here is I could make it so that now we don't do this closest hero d squared part anymore. I could take that out of there as well. So he's always kind of following us, but the reason he stops is because he gets to like that halfway point, right? And he's a little clingy. It's true. He's a little bit clingy. And you'll notice, see, I can't enter his square, which is what we wanted, and he won't enter mine, which is good too. But it's still not. It's not quite what we want. And there's a couple things there. There's a couple reasons it might not be. I don't know, but we can see, right? And you can see he oscillates kind of back and forth there. And the reason he's oscillating there is not because of the spring. The reason he's oscillating there is because of this notion of blocked. This blocked notion oscillates as well, right? So in some sense, what we have here, and I think this is kind of a problem that we want to solve more fully as well, is we don't have any way currently for people who are moving to think about where they're going to be. They only know once they get there. So really what we would prefer for our little dude here is we'd prefer for him to just stop on that square if he knows he can't move into the next square, right? But instead what he does is he tries to move into the next square, and when he finds that he would be in the next square, he sees it's occupied, so then he springs back to the previous one. As soon as he moves over the previous square, he finds he's okay again, so then he tries to move towards the hero, and that's when you get that oscillation happening, right? So, I think what we want to do is probably introduce another concept here, and I think we're going to want to use this for the hero as well when we sort of tune this head control. What I think we want to do is I think we want to have some way of saying what would the next traversable be if I went in this direction, right? So, if I was to go in the direction that I am planning on going, what would the next traversable be? And if that traversable is already occupied, I won't try to go there until I see that it isn't occupied, right? Okay. So basically, this code here, where we're doing block, this can probably stay in as sort of a failsafe for when somebody moves into a square that we were trying to go to. But what we want to do here is say, well, the target P being our occupying, we actually want that to be true, even if we're not blocked, if we see that the next square would have been blocked, right? So after we do this and we look at what the target P would be, we don't want to accept that target P unless we can get there safely. So I'm going to go ahead and say, let's just try this again here. And then I think we've gotten to the point, at least I'm fairly confident. No. That now would be a time to maybe start pulling some of this code out into helper functions so that they're easier to use for constructing brains, because I think we're going to want to do this sort of stuff a lot. Okay, so when we find the closest hero, this is the line we're going to execute, and instead what we want to do is like say that there's a target traversable, and we'll get that target traversal by saying, what's the head P, plus maybe a uniform step in this direction or something, right? So this is the delta that we're trying to go. We've got that closest hero P, and we've got the head P. And I'm just going to go ahead and say, let's like normalize or zero that. I think we've got a NAS function. So we've got that delta. That's the direction we're going in. And what I'd like to do here is just take that, say, if I was to move a certain distance forward in that delta, what would the next traversable be that I would be in, right? And we have there's a little bit baked in here, and I guess I'd say this like, default distance or something. There's a little bit of hand wavingness in there that we need to sort of systematize. I'll talk about in a second. But for now, let's just say we're going to move 1 unit in that direction, right? So if I was to move 1 unit in that direction, I'm going to get this target traversable. And I just want to see, like, is it occupied? So if it's not occupied, then I'm going to try to go there, right? And that's it. That's all I wanted to do. So, is occupied, I'm assuming we already know how to do, but I guess I just never made anything for it. You can see, I guess here, yeah, that we never really did, and anything that is this thing occupied? I guess that just wasn't a thing, it looks like. Now, it's a trivial thing. It's just, does it have an occupier? But I'd rather be able to just write is occupied and not have to worry about how these things were implemented, right? Because, maybe we change it further down the road, and maybe I forget or whatever. So since I just want to be able to say, hey, is it occupied, and know that I'm going to get something back. So here's the ref, and I believe all we have to do is this. I think. We'll see. I really should probably just define a B32X. But, destref undeclared identifier, that's true. So let's see if that is any better. And, oh dear. All right. So, yeah, not great. And I think that's probably just because it's not asking to move far enough. Well, but that looks like the opposite is happening. Is occupied. If the occupier is 0. Oh. Just had the sense of it wrong. Much better. Oh, texture download. Yeah, so it clearly needs to be able to do it slightly further than 1 unit, and that's the part I was talking about before. Now, let me explain that before I fix it, just so you can see. So, what I want to do here is, we're currently set up in a regular grid, but there's actually no reason why we have to be in a regular grid. Right? In fact, just to prove this point, sort of for people who might be confused about that, because I realize that we haven't spent much time really talking about it hardly at all. But if you take a look at add standard room here, you'll notice that I'm adding these, these entities in here with whatever, the traversables and stuff like this. And I'm adding them at particular locations and blah, blah, blah. So here's like this P with the world position and all that stuff, right? If I wanted to, I could add deltas to these. So for example, I could say that there's an offset. Oh, in fact, I've already kind of got one, right? You can see it right here. I was setting the Z offset, but I could, make there be an X offset. I could make that be a random bilateral on the series. And I could do an offset Y that's a random bilateral on the series. And, I don't know how far you could go on these exactly, but let's say you can go a quarter unit. And now when I create the room, you can, oh, well, that was not what I was expecting. I admit that. It looks like I may have been a little bit overzealous there in my changing of what the offsets were. My goodness. That should not have had that effect. I don't understand why that wasn't just a very, very small modification. Right? That should not have... Oh, right. Sorry. I didn't mean to overwrite it completely. My bad. All right. So let's make these. Now I can go back to what I thought was going to be reasonable value, and it was. I was actually overwriting the thing. I, for some reason, didn't make it a plus. So you can see in this case, right, there's really no reason why they have to be a grid, right? We have not written the code such that a grid is required. Everybody pretty much is just able to function on completely arbitrary maps. The only rule is that only one person is allowed to occupy one of these things at a time, right? And I don't know that we're ever going to make use of this particular feature, but since I don't actually know that we won't, this might be the easiest way to say it, I want to make sure that we can, right? And so we're still at the point where I'm not willing to give that up, and I think I'm never probably going to, because I think we're going to want to make some maps that have topologies that are a little bit different. So just, keep that in mind. So what that means is there's no way for the familiar to know something like what is the next square over, right? There's no way for it to ask that question semantically, because there is no logical definition of next square over. There's only a geometric definition of the next square over, which is like, if you gave me a direction, what would be the time when I hit a point next that became closer than the point I'm currently on or something, right? So we can make geometric definitions, and those definitions, we could make one that sort of coincides with our intuition, the intuition that we expect to have here, right? But we can't do something like, have some sort. There isn't. I guess all I'm saying is there isn't some hard and fast notion of what points to the left. So what I need to do is I need to basically cast across. So I need to take these little fellows, right, and I need them to kind of go like, oh, where would I be? What would I be going to if I looked a certain distance to the left? Hello, Monstar. So if I looked a certain distance to the left or to the right or whatever, if I'm doing that casting, I need to make sure that I look far enough that I'm going to get the next one, but not so far that I pick up one after it, right? And so really, I don't really want a query that's like get closest point. What I really want is get point in direction. But rather than write that at the moment, we should be able to just use the fact that these are relatively regularly spaced to sort of not address that particular query right now. But when we do spatial queries, we will probably want to do that, right? So what I'm going to do is I'm going to say, okay, we've got the sim region get closest traversable. I'm going to pretend that we've got another one that does get the thing in this direction. But then, I'm not going to implement it right now. But I think that's better so that we can at least see who's, what's the word I'm looking for? That way we can at least see who's using it when we have to go and re-implement it, right? So instead of get closest traversable here, we're just going to use basically the same logic. So I'm going to say get closest traversable along ray. And so what we'll do here is we'll just say, all right, in this sim region that we're talking about, if I start from this P and I go in this direction, what was the traversable that I will first hit? Right? And so I'm, again, not really going to do anything smart here. I'm going to just call our existing function, and it's slow and crappy, but that's just what's going to happen. And like I said, we can always speed all of these up later, so it's no big deal. So what I'm going to do is I'm just going to start by, sort of pulsing out along this line, and I'm going to sort of take sample points and see when I get to another one first. Now, there's a problem here, right? Which is that when we're doing this traversal along array, we want to skip the one that we're currently on. And so we kind of have this other slightly nasty thing we got to do here, which we got to say like, oh, skip this one, because we don't want to return the one that we're next to or whatever, right? Something like that. So I'm not sure exactly how we want to do that, but I think that's roughly what I want to do. Okay? So over here we would say get closest traversable along ray. We'd have the sim region. We'd say here's the head P, here's the delta direction. Then I would say, well, I don't want the one that I'm on, right? And I want you to just return to me whatever the target is. And I don't want you to look only for things that aren't occupied, because I want to know if it's occupied. That's the whole reason I'm doing this. So what I'm going to do here is say, all right, let's do a for I loop. Probe index equals 0. Probe index is less than 10. I don't know. Plus probe index. Maybe that's too many. We'll just say 5. And so then what I'm going to say here is, all right, we're going to take sample points out along this guy as we do sort of our sampling. And we'll say that like the sample P is going to be equal to wherever we started plus, the probe index, whatever that is, we're going to multiply that by our sample sort of distance, which we'll say is 1 unit. And maybe we'll even say it's 0.5 units. We'll take closer samples as we step out or whatever. So we're going to take that times the direction. That'll move us out to a new sample point. And then we'll just call get closest traversable, right? We'll call get closest traversable, and we'll see if it returns true. We pass the same stuff we were passing before, but now we're going to pass that sample point. And we're going to pass the result here, so we'll grab whatever comes back into that result. If we got a closest traversable, then all we need to do is say, well, is the closest traversable... Oh, you know what? I should pass the flags too. Is that closest traversable that it's giving me back, is that one the one that we were told to skip or not? So I can say, like, what is it? Is equal. If the skip one is equal to the result one, then we haven't found a match. But if they're not equal, then we have. And so then I would say that the result or found equals true. And we would break out of the loop at that point. Right? So that's really all we need to do there to modify the routine to work out along the ray. And now you can see that this guy is a lot more stable now that he's working that way. And he doesn't have that weird halting behavior, except when he's close to me and has to stop, right? Let's move up and get some more of these guys. Yeah. Let's see. And you know what I would like to be able to do? I would like to be able to see when these guys think they're blocked and not, and that sort of thing. It's kind of funny to leave these guys around. So another thing I kind of want to do right now, because we're almost out of time, so I don't know how much more stuff I'm going to have time to do here. In our profile, I did want to do one thing, which is I'm interested to know how much time we're spending in these functions, right? And since we made a bunch of tools for these, I don't remember what they are, if it's like count function or something like this. And so I just want to see what the profile is there. So let's go to simregion.cpp and just see what it is. It's a timed function. Because I suspect that we spend a ton of time in these spatial queries. They're really, really slow, and they iterate over lots of things. And so I just wanted to see how much time we were actually spending in them, and if my intuition was correct that that's where all our time was being spent. But I don't actually know. So yeah, there's 15% of the time in get closest traversable. Although inside BeginSim, we are still spending a lot of time in there, which I'm not really sure why. Probably because we're still copying giant entity structs around, right? I'm guessing, but I don't actually know that that's true either. Yes, you can really see that get closest traversable just taking a ton of time, right? And so that's what we want. I mean, that's good, because that is very specifically something that's easy for us to optimize quite a bit, right? We can get that down to probably taking like almost no percent of the time, and that'll free up a huge amount of our cycle count, which is good. I would like to know a little bit more about BeginSim, because I want to make sure I kind of understand where that time is being spent, and I don't necessarily know. So I would also like to kind of go in here and just see. So inside BeginSim, if we have this whole thing timed, we've got the triple loop, and then we're unpacking in the blocks. I'm assuming that mostly like that time is just spent in that unpacking process. Right, because this is just a lot of copying, I would think. So we'll see. I will also double check quickly just to see what happens to this when we do a build in release mode. There we go. Yeah, and so so in release mode, even now, that stuff is just irrelevant, though, I guess. So I guess it's mostly just a lot of checking and inefficiencies in the way it would be copying those entity structs and stuff like that. Because we still get a solid 60 hertz, like pretty much no sweat, even with that completely ridiculous junk going on. Which again, I think bodes really well for this entity system, because this isn't even a fast machine. This is a pretty slow machine. It's from 6 years ago, this machine. So if I mean, look at all this junk that's already happening on the screen. If that's not, and we're not doing anything yet to try and copy those entities in any sort of efficient way, I think we'd be fine. I don't think we're going to have a lot of trouble. Because remember, all these trees are entities, all these points are entities. We have a ton of entities, and it's just chewing through them like it was nothing. And we have done zero to help it. Yeah, I'm thinking that we've got so much processing power to spare, that just, I think, means this is going to be the right decision for this game, how we're doing it. Let's go ahead and zoom out just to see what the world looks like in this fashion. I'm not super sure why those aren't simulating. I guess it's just because this guy locked himself up. It looks like the snake trapped this guy. Pretty great. So anyway, yeah, I think that's good for now. I'm trying to think if there's anything else I want to do quickly. I just wanted to get a sort of baseline on that. But yeah, like I said, it's a pretty old machine. Trying to think if I should do anything else here, if I should just call it there. I don't want to start something that I can't finish. Yeah, I guess what I could do is maybe I could pull out something here. So let's take a look at some of this code and see. So here's the thing that's like get closest entity with a particular brain type, right? And that's probably going to be a pretty common function, right? That's probably going to be something fairly common as well. So that might want to be pulled out in addition, I'm guessing. Also, these sort of springy functions are very common, and I feel like those are going to want to get pulled out. Yeah, so, maybe let's do in the sim region, maybe in here, just so we're sort of building up a little rogues gallery of stuff that is spatial queries that probably need to be accelerated. I could say that this thing is a get closest entity with brain or something. And that could be, here's a point, and here's the sim region. And I'm going to tell you what the brain type is. And you're going to tell me what the result is. Right? That seems useful because then this stuff becomes a lot simpler. The other thing we can do is this thing here is just say like, oh, what's the radius? And start it out that way. So yeah, and we could make this a default parameter, so we could say something like, oh yeah, we'll do a 20-meter radius or who knows what as our default, and so when people don't care, they just get that radius, and if they do care, they get a different radius, right? And probably what I would do is, since we have to compute it anyway, I would do like closest entity thing, and I'd say like, let's just give them all the information. Did we find one? What was it? And what's the closest, what's the distance squared? Because they may want that distance squared to do something with. So I feel like that's a good thing. And we could also give it the delta. So like, since it's doing a bunch of computations here, we might as well return those computations so that they don't get duplicated for no reason, right? So here's the closest entity result. And I guess I'll just initialize found to false. And I guess closest hero, well, I might as well, I guess, initialize them all for now. And we'll initialize the distance squared. To that max radius. Then in here we can just say like, okay, every time we find one, we just say that our result entity is going to be the test entity, our result distance squared is going to be the test distance squared, and our result delta is going to be the test delta. And I'll compute that test delta explicitly here rather than as part of the expression, just so we can save it in case they want it outside. So there's the test delta. The P is not head P, obviously, it's just the P that gets passed in now. There's that brain slot type. And I think that's it, really. Yeah. Now, we're probably going to need to expand this notion a little bit to something a little fancier here. And this is obviously always a bit of an annoyance with C++. You can't pass things in very easily, like closure testing there. And I don't really want to go down the Lambda route now, but so, you'll notice this is being a bit of an annoyance. But for the most part, we should be okay. So there's that result. And that's result distance squared. There we go. And so in here, what I'm going to do is say, well, okay, when we do these spatial queries, and I'm doing this whole bit here, instead, I'm just going to call, and I realize I'm a little over time, so we'll stop in just 1 second. I'm just going to call this and say closest or whatever equals get closest entity with brain. I'll pass the sim region. I'll pass the head p. I'll pass the brain type that I wanted. And that'll just work, right? And then I can do if the closest found. Well, I guess I don't need the found. I guess it's just the entity pointer. I'll do the closest entity. And everything else should be fine. This is that delta, so I guess I don't have to compute that. I mean, that's it right there. Yeah, we don't actually need this anymore either, right? Because that's just not necessary with the ray stamping. So really all we need to do is say we need to normalize this. We've got the head P, the head occupying target traversal, occupying closest to a P. So really this is the only thing that we need to modify here. So. And so then we just kind of cleaned up that code a little bit and just have it now have a nice utility. And now, anyone can ask what the closest thing is of a particular brain type, and off it goes, right? So yeah, I think we're good. I'll go ahead and go to the Q&A. So if you have any questions, ask away. Mm. Gary Johansson. Any thoughts on multi-threading the entity system? Well, there's two things there. One is, it depends what you want to multi-thread. One thing, oh my god, Insobot. That's amazing. Sorry, Insobot just said something awesome in the chat. Anyway, point being, there's two things you might think about multi-threading wise. One is to multi-thread the current entity sim to make it faster. My thought on that is that just seems dumb because we haven't optimized anything in it yet. We're running literally thousands of entities through it at this point, I guess. Maybe not thousands, but we're running like probably a couple hundred through it. And it's literally not even touching the profile in release mode. So, and it's on a 6-year-old machine. So I'm guessing that like making the entity sims run faster for one sim region is probably not, it's just probably not going to be worth it. I mean, we'll see. Maybe when we get to further down the line, there'll be, more stuff that does that. So I don't think that's super relevant. If we want to multi-thread the entity updates of other places in the world, that is already, I think, free, actually. I mean, there might be a couple things we would have to do, like add brain and stuff like that. There's some things we may have to make sure call atomic adds rather than regular adds. But otherwise, our sim region stuff takes place entirely inside the sim region. So you could have all 6 worker threads all run a different sim region, and they wouldn't interfere with each other in any way. So the only thing we have to make sure that we support is when we add new things, we have to make sure that when we call when we get a new ID or things like that, we do those atomically. That'd be it. And so we already are completely multi-thread compatible, I think, for scaling that way. And that's kind of intentional because I wanted to be able to scale that way. So basically, if there's somebody out, if there's more things happening elsewhere in the world that are very far from the player so they wouldn't be getting simmed, I want to be able to run separate threads to keep them simming. And so that is kind of something I would like to do. And so that's kind of a little bit somewhat conscious. The other thing that we might have to thread in the future, and I don't know, is if we have any kind of really heavyweight AI thing that happens for some reason, like some very specific kinds of pathfinding that are expensive or who knows what, maybe that's a place where we would have to start thinking about how we're going to deal with it. But, at the moment, not a thing. Ever. How many more times will you get hit with a texture upload issue before you actually fix it? It's just not appropriate to fix it now, right? Like I said, on stream I don't have the luxury of fixing things that are broken when they happen, because if we're in the middle of something, I try to keep it so that the things are relatively coherent. So since it doesn't cause us any actual problem, you just hit close and then start it again. It won't be till we go work on the renderer again. Rome, do you have a max entity count at the sim region on the debug display? We don't at the moment. Inside sim region, when we are done, so when we do begin sim in here, we should be able to, at the end of the whole thing, we should be able to say entity count. And I don't know what that value would be, but let's find out. So it's 740 at the moment. Let's walk out to a place where we'll hit more stuff. So 1121. Like I said, it's crazy how fast machines are these days. The fact that in the release build, the fact that literally didn't even show up on the profile in any, like, it wasn't even 10% to do 1100 entities at 16 frames a second is crazy, considering all of the pack unpack we're doing is not a pack unpack at the moment. It's a block copy. But that's just, computers are crazy fast. That's why I'm always so annoyed at how slow the web is, because it's ridiculous how fast computers are. You wouldn't think so if you went to use Gmail, but computers are actually very, very, very fast. I see no more coding questions. Out of topic. Milton seems to be treating Wacom input as mouse input. Restart Milton. We'll look into it. How are you able to tell this? But, sure. Close. Milton. Is this better? It sure seems it. All right, I think there are no more programming questions, so I will go ahead and close things down. Or try to close things down? There we go. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can pre-order the game at handmadehero.org, and it comes with the source code even as we speak, so you can play around at home with the game. We also have a forum site if you have questions about the series and you would like to talk about said questions. We have a Patreon page if you'd like to support the video series. We have a schedule bot if you want to know when we're going to be live, and we have an episode guide if you're trying to catch up with past episodes. That is it for today. I will be back for the last stream of this week tomorrow, Friday. Until then, have fun programming, and I will see you guys on the internet. Take it easy, everyone.